First vector, 2 minus 3, 0. That's my second vector, minus 2, 3, 5. That's my third one, 4 minus 6, 2. And this time, I will try to address the question of spanning, whether my set is spanning. So I do my B as a symbolic vector with symbolic components. And again, I'll try to answer the question when my B belongs to the span. We already know, I'm not sure if you registered that. The first three vectors here, they are the same as in example 4. So we know for sure there are some combinations of those B which do not work. We just found one in example 4. But in this example, we aim for more. We aim to find the conditions which will ensure this is true. If the question was whether this set of vectors is spanning, the answer is no, it's not spanning. Because we found one element which fails. Look at the example 4 again. In this example, it's the same three vectors, and we found an element which falls outside the span, which means span is not R3. Right? It cannot be R3 because we have one vector which is in R3 but not in span. And hence it's not spanning. That's the extra comments which I have to make about the example 4. Now in example 5, we're about to do right now, we take the same three vectors, but now we try to address the issue when this B, for which B is actually this is true. That's my setting, the same three vectors, but now parametric version or conditional version. So I start off with the definition of condition being in a span, linear combination of my vectors with unknown coefficients equals to this B. This is a system of linear equations, and this is the augmented matrix of that system. Vectors arranged in columns. And right-hand side with my B's. We saw it before. We take it to the row echelon form. I skip some intermediate steps. This is the row echelon form. And we ask the same question. How many pivots we have and where they are? 3 rows, at most 3 pivots. We can spot 2 immediately, right? This is the first pivot. This is the second pivot. What about this one? Well, that depends. If this expression entirely is 0, it's not a pivot, and the system is solvable. On the other hand, if this expression is not 0, it will become a pivot, and the system is not solvable. And hence the answer. The span, or B belongs to a span, if and only if this condition is satisfied. Well, actually, the way I said it is actually, what I said is correct, but what is written is not entirely correct. Because there's no statement here. What should have been here is this. I'll tell you. I just do like this. What should have been here is this. I should take this. I should do it like this. That will be a correct statement, the one which I voiced orally, but I didn't really type it correctly. This is the statement I just said. B in a span, if and only if this condition is satisfied. All right? Or, now I can actually fix this correctly. The span is in fact this object. Look at this. This relation, alternatively, I can set it like this. The span of 3 vectors coincides with this object, right? Because the vector belongs to a span if and only if this is satisfied. And for this object, actually, we had another name, didn't we? This is something which I called matrix null space a few lectures ago. This is something I called matrix null space. So my span of my three vectors actually coincides with the null space of a matrix A. And if you remember, I said that actually you have to specify the matrix exactly. That's my specification. The matrix is of size 1 row, 3 columns. And the entries of that matrix are like this.